Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. In fact, I'm very delighted to see you once again. If you are new here, kindly share, like, comment, and subscribe for more interesting videos and updates. We've covered a whole lot of stuff under integration by substitution, and today ends the entire topic, integration by substitution. So after this, we are going to dive into another area of integration by substitution, but we are going to consider the trigonometry identities. Okay, all right, so let us grasp the basic ones. All right, today we are going to consider the case 3. Okay, the case 3, and for the case 3 we cannot apply the concept, the same concept from case 1 and case 2. Okay, for case 3 it is entirely different. Why is it entirely different? We realize that in case 2, whenever you differentiate the inner function, okay, the differential of the inner function is the coefficient of the whole function given. For example, when I differentiate this inner function, okay, I will get a certain result, and that result is the same as the coefficient. Do you get it that way? But in case 3, let us see. 2x minus 1, when I differentiate 2x, I have what? I will get 2. But here, the coefficient is what? Is x. That alone should tell you that case 2, this isn't what? Case 2. So let's see how we can go about such questions. So I have the integral of x multiplying 2x minus 1 raised to an exponent of 3 dx. For these cases, this is what we are going to do. Since it is u-substitution or simply substitution, we are going to say, let what? U be equal to, let u to be equal to 2x minus 1. You differentiate u with respect to x, I have du over dx, which is equal to, that's 2, right? When I make dx the subject, I have dx is equal to du all over 2. That's it. Now for case 3, we are going to make x the subject. So we know that u is equal to 2x minus 1. You make x the subject, so I have u then plus 1, which is equal to what? 2x. You divide here by 2, here 2 by 2. So therefore, x is equal to u plus 1 all on 2. So we are going to substitute this and that into our final equation we are going to develop, or expression we are going to develop. So therefore, I can say that the integral of x multiplying 2x minus 1 raised to an exponent of 3 times dx is the same as integral of x. What is the value of x? X is equal to, do you get it that way? U plus 1 all over 2. Then this expression is multiplying this expression, 2x minus 1. We said 2x here, 2x minus 1 is the same as u. So I have it times u this way. And u is raised to an exponent of what? Of 3. So times 3 this way. As simple as that. Then dx. What is dx? Dx here is dx is equal to, that's times du over 2. Let's see what we can do here. So I have this integral of u plus 1 over 2. Okay, multiplying u to the power 3, right? Then multiplying du all over 2. So this is the same as 2 times 2 is 4. So I have 1 over 4 out. If you are new here, kindly visit my previous lecture videos on case 1, case 2, and introduction to integration. So therefore I have u plus 1 multiplying what? U to the power 3 times my du. So this is the same as 1 over 4 and the integral of u times u to the power 3 is u to the power 4. Then plus u3 times 1 gives u to the power 3. Do you get it that way? And we are integrating this with respect to have this, right? So for integration, you add 1 to the power, the original power, then you divide it by the new power, right? So this is the same as, note this, 1 over 4 is multiplying this, and it's also multiplying that. I have 1 over 4 this way. So you add 1 to this, you have u to the power 5, then all over 5. Then plus, you add 1 to this because we are integrating both terms. So we have 4, then all over what? All over 4. Plus my constant of integration, since it's what? It is an indefinite integral. So this is the same as u to the power 5, then all over 5 times 4 is 20. Then plus u to the power 4, all over 4 by 4, 16. Then plus my constant of integration, which is c. But u equals, viewers, yeah. So u equals 2x minus 1. So I have 2x minus 1. So we substitute this into this. So I have u to the power 5, which is u, that's 2x minus 1, which represents the u to the power what? 5. Then all over what? 20. Then plus u to the power 4. And u represents 2x minus 1 to the power 4. Then all over 16. Then plus my constant of integration, which is my c. Viewers, this is the end of this trivial question.